Hello everyone. In today's class, we discuss about Young's double slit experiment. Thomas Young is the first scientist who explained the interference with the help of experiment. For this experiment is known as Young's double slit experiment. Okay. For that, first he took the source of light. He took the source. Let us call that source. This source is common bulb or common light which emits monochromatic light. Source emits monochromatic light. Here, mono means single. So monochromatic, chrome means color. So monochromatic light means single colored light. So source emits single colored light, and it took a single slit like this. After this, again he took double slit because to get the coherent sources. What is coherent source? The sources which emits light of same amplitude, same frequency and same wavelength. That is known as coherent sources. So to get the coherent sources, we took double slits. Let us call this slit as S. Okay, and this slit double slits are known as S1 and S2. Okay. So when light from the source is incident on the single slit, after this it incident on the double slit. So interference pattern is obtained, and this interference pattern is observed with the help of screen. This is known as screen. Interference pattern is obtained with the help of screen. Okay. Here the distance between the two slits, the centers of two slits, is known as small d. So small d is the distance between the slits. Okay. Next, the distance between the screen and double slits is known as capital D. Capital D is the distance between the screen and the slit. Small d is the distance between the double slits. Okay. Small d is the distance between the two slits, and capital D is the distance between the screen and slits. Okay. So according to him, when source emits monochromatic light, so this monochromatic light is made to fall on the single slit. Monochromatic light is made to fall on the single slit. Here the single slit is to act as a point source. You know that the point source emits spherical wavefront. When light from the source is incident on this small source, point source, that means slit S, spherical wavefronts are formed like this. Okay. And then this spherical wavefronts are made to fall on both the slits, that is slit S1 and S2. Again, spherical wavefronts are formed at S1 and S2. Okay. Again, this light is passed to the slit S1 and S2. Again, spherical wavefronts are formed. So these spherical wavefronts, after some time, these spherical wavefronts are overlap with each other. That means they are superposed on each other. When they are superposed on each other, the interference pattern is observed on the screen. Okay. Again, once again I repeat that. When light from the source is made to fall on the slit S, spherical wavefront are formed. This spherical wavefront is incident on both the slits, that is S1 and S2. Again, spherical wavefronts are formed. After certain period of time, this spherical wavefront goes on. This spherical wavefront superpose on each other and produces interference pattern. So this interference pattern is obtained on the screen. So the interference pattern is like this. You will get interference pattern as like this. Okay. This is the central bright fringe. Okay. These boxes are called dark fringes. These are known as dark fringes. These are known as dark fringes like this. Okay. So interference pattern is obtained like this. That means it consists of alternative dark and bright fringes. Here one is dark fringe, another one is bright fringe. Again dark fringe, bright fringe, dark fringe. But the central fringe is always bright. Okay. So again this is bright, this one is dark. This is bright, this one is dark. So this is bright, this one is dark. Like this interference pattern is obtained. This alternative bright and dark fringes are due to the interference, that is constructive and destructive interference. We know that the bright fringe is obtained due to constructive interference and dark fringe is obtained due to destructive interference. When the wavefront from S1 and S2 are overlapped with each other, if crest of one wave falls on crest of another wave, or trough of one wave falls on trough of another wave, then constructive interference is obtained. So this constructive interference gives bright fringe. If suppose crest of one wave falls on trough of another wave, or trough of one wave falls on crest of another wave, we get destructive interference, that means dark fringe. So in the interference pattern we get alternative bright and dark fringe, and the central fringe is always bright fringe. Okay. Next, the distance between any two consecutive crusts the distance between any two consecutive dark fringes or any two consecutive bright fringes is known as fringe width. The distance between any two consecutive dark fringes or the distance between any two consecutive bright fringes is known as fringe width. Okay. What is fringe width? So fringe width is the distance between the any two consecutive bright or dark fringes. Okay. This fringe width is denoted by beta. Okay. The central is called as central bright fringe. After this first band is known as first dark fringe. This is the first dark fringe. This one is the first bright fringe, and this one is the second dark fringe, and this one is the first bright fringe, second bright fringe, like that. Okay. Second bright fringe. So in this way, it will get the interference pattern on the screen. Okay. Based on this Young's double slit experiment, now we derive expression for fringe width. Derive an expression for fringe width. This fringe width is known as beta. Fringe width is denoted by beta. So now we want to derive the expression for fringe width. To derive this expression, it took a double slit, this is called double slit. Let us call this slit as S1 and this slit as S2. The center between the two slits is known as S. Okay, S1, S and S2. Okay. Next, to observe the interference pattern, we took the screen like this. This is the screen. And this double slit can be taken as capital D. This is capital D. The distance between the two slits is known as small d. Don't confuse this capital D with small d. Capital D is the distance between the screen and slit, and small d is the distance between double slits. Okay. So this is the point on the screen. Let us call this point as O. The line joining the source S1 and the screen can be taken as A. The line joining the slit H2 and screen will be taken as B. Okay. When light from the source is made to fall on these double slits, so these double slits act as coherent sources here. S1 and H2 are the coherent sources. When two coherent sources produce spherical wavefront like this, they produce spherical wavefront like this. These spherical wavefront overlap on each other and they produce interference pattern on the screen. When light from the source S1 or wavefront, don't call this as light, that is wavefront from S1 and S2 are overlap on each other and produces an interference pattern at the point say P. At P is the point on the screen where the interference pattern light from the source S1 and H2 are produced interference pattern. Okay, P is the point on the screen where the interference pattern is produced by the S1 and S2. Okay, let us call this distance from point P to O as x. X is the distance between the point P and origin, that is O. If this distance is D, then that means the complete distance AB is equal to D. Then AO, what is AO? AO is half of D. That means D by 2. AO is the D by 2 and also BO is equal to D by 2. AO and DO are is equal to D by 2. Okay. S1 and H2 are the two coherent sources. P is the point on the screen where the interference pattern is produced from these two sources. X is the distance between the O and T. Capital T is the distance between screen and double slit, and small t is the distance between the two slits. So light from the source S produce an interference pattern on the point P, but center bright fringe is formed at the point O. After this, alternative bright and dark fringes are produced. From figure, path difference is equal to, what is the path difference? Path difference at the point P is equal to S2P minus S1P. Path difference is equal to S2P minus S1P. Okay. Again from the triangle S1AP square, from right angle triangle, S1AP, this is S1AP. According to Pythagoras theorem, S1P square is equal to S1A square plus AP square. So S1P square is equal to S1A square plus S1A square plus AP square. Then S1P square is equal to, from the figure, S1A. What is S1A? S1A is nothing but distance between the screen and the slit, that is capital D. So S1A square becomes D square plus AP square. This is the distance AP. So from the figure, OP is equal to X. Then AP is equal to what? AP is equal to OP minus OA. AP is equal to OP minus OA. Here OP is X. O minus OA is D by 2. X minus D by 2. Okay. AP has X minus D by 2 whole square. Okay. So this S1P square is equal to D square plus, it is in the form of A minus B whole square. A minus B whole square is equal to A square plus B square minus 2AB. So A is X, so X square, B is D by 2, that is plus D square by 4 minus 2AX. A is X, 2AB, B is D by 2. So 2 get cancelled, you will get XD. So minus XD. D. Okay, we call this as equation number 1. Again, from the another right angle triangle, what is that? S2PB. From right angle triangle. What is that right angle triangle? S2BP. S2BP. Again, we apply the Pythagoras theorem for this triangle. That is S2P square is equals to S2P square plus BP square. So S2P square is equal to S2B square. S2B square plus BP square. BP square. So that will be equal to, from the figure, S2B. S2B is nothing but the distance between the screen and the slate. So that is D. So S2B square can be written as D square, capital D square, plus BP square. What is BP? BP is the BO plus OP, or OP plus BO is equal to BP. So this can be written as PO plus BO, that is X. PO is nothing but X, BO is nothing but D by 2, X plus D by 2. So that X plus D by 2 whole square. Okay. So this S2P square is equal to D square plus, again it is in the form of A plus B whole square. So A plus B whole square expands as A square plus B square plus 2AB. Here A is equal to X and B is equal to D by 2, will get X square plus B square means D square by 4 plus 2AB, that is 2 into X into B, D by 2. Again here also 2 get cancelled, we will get plus XD. Okay, we call this as equation number 2. Next, subtract equation 2 from equation 1. Subtract equation 2 from equation 1. I will get LHS as S2P square. What is the LHS of equation 1? Minus S1P square is equal to equation 2. Right hand side. What is the right hand side? D square plus X square plus D square by 4 plus XD minus of this, minus of D square plus X square plus D square by 4 minus XD. Okay. So here this is in the form of A square minus B square. S2P square minus S1P square and as A square minus B square. A square minus B square can be expanded as A plus B into A minus B. So S2P square minus S1P square will be written as S2P minus S1P into S2P plus S1P. That will be equal to D square plus X square plus D square by 4 plus XD. Here plus into minus, minus D square, plus into minus, minus X square, plus into minus, minus D square by 4, minus into minus, plus XD. The plus D square, minus D square get cancelled, plus X square, minus X square get cancelled, D square by 4, D square minus D square by 4 get cancelled. Remaining is X plus D plus X plus XD plus XD. So XD plus XD equals 2XD. So S2P minus S1P into S1P plus S2P is equal to 2XD. Here, we want to derive the expression for part difference. What is part difference? S2P minus S1P. So this equation becomes S2P minus S1P is equal to 2XD plus S2P. Okay, this is the expression for path difference. S2P minus S1P can be written as path difference. So, path difference is equal to 2xd divided by S1P plus S2P. Here, D is very small. D is very small. Which D? That is small. D is very small. That means the distance between the two slits is very small. Then X is also negligible. That is X is also small. X is also small. If D and X are very close, that means they are very small, then S1P is approximately equal to S2P. That will be approximately equal to D. That is the distance between the screen and the slits. Okay. So path difference is equal to 2xd by S1 is P, S2 is P. Sorry, S1P is D and S2P is approximately equal to D. So D plus D becomes 2D. 2 get cancelled. Remaining path difference is equal to, what is the path difference? XD by D. Okay. In the previous session, we know the condition for path difference. We know the condition for path difference for right fringe. Path difference for bright fringe, that means for constructive interference. For bright fringe means for constructive interference. What is the condition for path difference for constructive interference? That is path difference is equal to n lambda. Path difference is equal to n lambda, where n is the integer and lambda is the wavelength. Okay. So here path difference is xt by d. Xt by d. That will be equal to n lambda. Okay. So this expression can be written as x is equal to n d lambda by d. X is equal to d n lambda by d. Okay. This for nth fringe, this is the expression for x, the distance between the bright fringe and its sudden fringe. But for nth bright fringe, this x can be written as xn. For nth bright fringe, not dark fringe, for bright fringe. For nth bright fringe, xn is equal to n d lambda by d. Okay, but we know that fringe width is the difference between the any two consecutive dark or bright fringes. We take the bright fringe. We consider here bright fringe. So the fringe width is the distance between the two consecutive bright fringe. First we take xn. So consecutive for this is x. Consecutive bright fringe for this is xn minus 1. This is 1, 2, 3, etc. up to n. If this is n and the previous one is n minus 1, like this. Okay. So xn minus 1 is equal to, instead of n, we shall write n minus 1. So n minus 1 into d lambda by d. So distance between these two consecutive fringes is known as fringe width. So beta is equal to, what is beta? So beta is equal to xn minus 1. So here xn is n d lambda by d minus xn minus 1 is n minus 1 into d lambda by d. Here common factor for both the terms is d lambda by d. D lambda by d. Remaining is n. Here take d lambda d by as common factor. Remaining is n minus 1. But minus of plus of minus into plus is minus n. Minus into minus is plus 1. Okay. where minus n plus n it cancels. Remaining is 1. So all into d lambda by d is d lambda by d. So fringe width beta is equal to d lambda by d. This is the expression for fringe width. Okay. Where beta is the fringe width, d is the what is capital D? Capital D is the distance between the screen and the slit. Lambda is the wavelength of the light used, and d is the distance between the slits. Okay. So beta, what is beta? Beta is the distance between any two constitutive bright fringe or dark fringe. Okay. So this beta, that is fringe width, depends on distance between the screen and slit, wavelength of light used, and the distance between the coherent sources. Okay, this is very important expression in the board examination. The last 5 marks question, that is derive an expression for fringe width. This is very important. Okay, intensity distribution pattern for interference is as follows. This is the intensity distribution pattern occur for interference pattern. Okay, so this is the central bright fringe. We know that for in interference pattern we get alternative bright and dark fringes. Bright fringe is due to constructive interference and dark fringe is due to destructive interference. For bright fringe, amplitude is maximum. So for dark fringe, amplitude is minimum. So this is the minimum amplitude point. So this is the dark fringe. So this is the maximum amplitude point. Therefore, this is bright fringe. Again, this is dark. This is bright. This is dark. This is central bright. Again, dark, bright, like this. So this is the intensity pattern for interference pattern. Intensity distribution pattern for interference. Okay. Suppose if two waves of different amplitude, say A and B. So A is the amplitude of the first wave and B is the amplitude of second wave. On superpose on these two waves, we will get resultant amplitude as R is equal to square root of A square plus B square plus 2AB cos phi. If two waves of different amplitude, that is A and B, superpose on each other and produces an interference pattern, and the resultant amplitude is given by R is equal to square root of A square plus B square plus 2AB cos phi, where R is the resultant amplitude, A is the amplitude of the first wave, B is the amplitude of the second wave, and phi is the phase difference. Okay. If R and resultant amplitude is maximum, resultant amplitude, that is R is maximum amplitude, R is maximum when R is maximum, when cos phi is equal to plus 1. Resultant amplitude is maximum when cos phi is equal to plus 1. If cos phi is equal to plus 1, this equation becomes as R maximum is equal to square root of A square plus B square plus 2AB into cos phi. Cos phi is plus 1. So 1 into 2AB is 2AB. So this is in the form of A plus B whole square. Then R maximum is equal to square root of A plus B whole square. Again square root it cancels. Then R maximum value is A plus B. For this case, resultant amplitude is the sum of individual amplitude. Okay. Next, resultant amplitude is minimum. Resultant amplitude is minimum. Resultant amplitude is minimum. When the resultant amplitude is minimum, when cos phi is equal to minus 1. Resultant amplitude is maximum when cos phi is equal to plus 1. And resultant amplitude is minimum when cos phi is equal to minus 1. Then this equation becomes R minimum is equal to square root of a square plus b square plus 2ab into cos phi, that is minus 1. So this is the form of a square plus b square minus 2ab, that is a minus b whole square. So r minimum is equal to square root of a minus b whole square. Here also square root we cancel, then r minimum is equal to a minus b. This is the minimum amplitude. Okay, for minimum amplitude, the amplitude of the two waves are subtract with, individual waves are subtract with each other. Okay. What is the condition for maximum amplitude? For maximum amplitude, cos phi is equal to plus 1. Then for minimum amplitude, cos phi is equal to minus 1. Okay. Then R maximum by R minimum is equal to what is R maximum? A plus B. What is R minimum? A minus B. So R maximum by R minimum is equal to A plus B by A minus B. We know the relation between intensity and resultant amplitude. What is that? Intensity of the wave is directly proportional to the square of the resultant amplitude. I is directly proportional to R square. Okay. I maximum, maximum intensity, that is intensity is maximum when amplitude is maximum. So I maximum is directly proportional to R square, that is R maximum square, that is A plus B whole square. So I minimum is directly proportional to the square of the minimum amplitude, that is A minus B whole square. So I maximum by I minimum can be written as A plus B whole square by A minus B whole square. R maximum by R minimum is equal to A plus B by A minus B, but I maximum by I minimum is equal to A plus B square, A plus B whole square by A minus B whole square. You remember only formulas. Okay.